Welcome to section 10.4, triangles, quadrilaterals, and other polygons. Pause the videos often, complete all the U-tries, and do the examples along with me. We've got a lot of topics, a lot of content to cover here. And please take your time reading over these slides. So what we're going to be doing here is we're going to be studying some of the basic two-dimensional geometric shapes that students learn in elementary school. So we're talking about triangles, squares, rectangles, and other shapes. We're going to describe their attributes based on the sides and the angles. And by attending to these attributes, we're going to classify them into categories. And we can then examine how the categories are related. So we'll see that a given category of shapes can often be described with different lists of attributes. And then we're going to choose succinct or concise lists of attributes to define the shapes. And then at the end of the section, we examine a variety of ways to actually make the shapes. So let's look at some terminology here. A two-dimensional shape is a flat shape that lies in a plane and is connected and closed. So we've got no loose or dangling ends. And for shapes made of line segments, every endpoint must meet exactly one endpoint of another segment. They're not allowed to cross. So we're not talking about shapes like that. And we're not talking about shapes that don't close, okay? So we're going to do explorations in this section and future sections. And I really encourage you to pause, get any of the material, scissors, paper, whatever it is, and then complete these explorations before moving on. The reason is that it's important to uncover the material rather than just listening to me explaining what it is and why it is and memorizing facts. So the explorations are extremely important for your understanding so that you can pass this along to your students and model how to do this in your own classrooms. So let's start here. You're going to pause the screen and you're going to complete this explore to the best of your ability. And when you've completed this and you've got some things down, then you can move on. So in this one here, you're examining the images, you're reading it over, and we're just basically trying to understand how students categorize, miscategorize, recognize, observe, and then any other observations. Press play when you have completed the entire exploration. Also note that these don't necessarily have right answers, so I won't be showing you the solutions to these problems so much as then applying what we learned in the explorations as we solve future problems and define certain attributes. When it is important, I will show you how to do some of these problems, but in general, the explorations do not have one correct answer that I'll be showing next. So now that you've completed your exploration, let's move on to determining shape. So how do we know if a shape is a triangle, square, or rectangle? Very young children decide if a shape is of a specific type just by looking at it, right? So what does it look like? If it looks like, oops, sorry about that. I thought I was still in highlighter here. If it looks like a door, then it's a rectangle. If it doesn't look like a door because it's too long or too skinny or because it's tilted, then it isn't a rectangle, even if it is. So when we only attend to the overall look, it's not a reliable way to identify it. So the mathematical study of shapes begin when children learn to consider a shape's parts, the properties of the parts, and the relationships among those parts. It is by considering those specific parts and properties that we can then reliably identify them, classify them into categories, and determine how those categories are related. So to categorize, we usually look first for how many straight sides a shape has. So now we're going to study four-sided shapes. We call those quadrilaterals. So a quadrilateral is a closed shape. So if you look at these open shapes here, right, this is open. It's not closed. That do not cross each other. So we are a closed shape. They do not cross each other. See how this crosses here? So these are not quadrilaterals. And so we're looking at shapes that are made of line segments, right? So line segments. See how this is a little bit rounded. So these are all quadrilaterals, and quad means four and lateral means side. So within the category of quadrilaterals, there are subcategories. For example, squares and rectangles. To describe a category, we'll need to focus on the properties. We've got another explore here. Pause, spend as much time as you need here on this. Remember, uncover the material on your own, and when we come back, we'll uncover together as a class. Press play when you have completed your exploration. All right, so you've played around with the identifying, classifying shapes. Now we're going to do that. So when we identify and classify shapes, we consider the number of sides and angles, the lengths of the sides, the sizes of the angles, and the relationship between sides. So are they parallel, perpendicular? We might also consider symmetry, but we don't consider some attributes that might be important to children. So we're not going to be talking about color or orientation up and down, right? A lot of students can say, hey, that's a triangle, but they don't know that that's a triangle. And then again, the overall shape. So these things are not considered when we classify and identify. So we've got another explore here. Take your time, very important here. Go through this, uncover the material, and press play when you're ready to move forward. All right, let's classify shapes into categories. So when you classified the shapes into that exploration, which is just a class activity from your back of your book, you probably noticed that some categories contain exactly the same shapes, even though they were described by different properties. And so that's going to lead us to defining the categories of shapes. So properties to define special quadrilaterals. So what's the difference between these three categories? Okay, a quadrilateral that has 4 right angles. Okay, what about a quadrilateral that has 4 right angles and opposite sides? What about a quadrilateral that has 4 right angles and opposite sides of the same length? So take a moment before I unveil this, make a prediction, draw some pictures, make sense of the problem. And so the answer is there is no difference. It turns out that each of these descriptions is the exact same collection of shapes, rectangles. If a four-sided shape is a shape, if a four-sided shape has 4 right angles, then it automatically has opposite sides that are parallel and the same length. How can that be, and why is that so? Well, that'll be uncovered later. But because we can specify the same category as shapes by listing different collections of property, we have some choice in how we're going to define it. So it's worthwhile to pick a short list of properties to define. So why? To decide if a shape is or isn't a rectangle or some other type of shape, students will check to confirm that all the defining properties hold. So a short list just means less checking. So let's look at those properties. Again, you uncovered this in your exploration. And if you want to go back and try it again or look at the categories, go for it. Some of which consist of the same shapes. Based on what you found, what short list of properties would you use to define the set of squares? So go back, look at your exploration, rectangles, rhombuses, parallelograms, and then compare what you found to these standard definitions. So these are the standard definitions that we're going to be using from this book. And one important thing is that, and we'll explore this later in your problems, but some books define a trapezoid as a quadrilateral with exactly 1 pair of opposite sides. Our book says at least 1, and we'll explore what differences that means later in the section. So again, we're still talking about that exploration. That's why it's so important that y'all do them. So in that exploration, you probably noticed that some categories are subcategories. So an important consequence of this is that a given shape can belong to more than one category. And maybe you already knew that, but making sense of it for yourself and for your students is important, rather than just saying, hey, a square falls into all these different categories. But why? So let's look at this square. A square, and we're going to look at these different categories, and I'll make them a little bit bigger here. So a square is a quadrilateral with 4 right angles, but it also is a quadrilateral with just 4 right angles, right? And it also has sides that are all the same length. And it also has opposite sides that are parallel. So when we look at this, we can see that we can define a square as all these other categories as well. And they give you a little hint here. Teachers can point out that squares are special kinds of rectangles. You could call them square rectangles as you start to introduce those shapes. So how do the hierarchies come about? So let's think about this question in terms of lists of properties. If a list only has one property, 4 straight sides, then many will satisfy that property. But if we add another property, 4 straight sides, 4 right angles, then only some shapes are going to fall into that category. And so the more properties we add, the fewer shapes satisfy all those properties. So if we start with a really long list of properties, 4 straight sides, all sides the same length, 4 right angles, then as we remove properties, we get larger categories. So let's look at this hierarchy. All right, so we start with squares. It's the most restrictive, right? We start with all these 4 straight sides, all sides the same length, 4 right angles. And then we take away a property. We say, okay, hey, guess what? All sides don't have to be the same length. Well, once we take away that restriction, we get rectangles. And now we get this new set of shapes. Well, let's say we take away those 4 right angles. But we add a property and say, hey, okay, they don't have to have right angles, but all the sides need to be the same. And then we get to keep our squares, but we get to add some new shapes that don't have right angles. Well, what about if we take away the angles completely and the side lengths? We say, hey, 4 straight sides, but now the opposite sides have to be parallel. Look at that, we get the rectangles back, right? Because now we don't have a side length restriction. And we get to keep our rhombuses because we don't have an angle restriction. And then when we just move to quadrilaterals, the only requirement for a quadrilateral is 4 straight sides. Now we get everybody, including trapezoids. So we're going to pause the video here, come back to see examples and more problems in the next video.